Now we will talk about the law of exponents, a very important topic when you are learning about exponents and power. What is law of exponents? Now, exponents follow certain rules that help in simplifying expressions, which are also called its law or rules. So I will write it down for you. Exponents follow certain rules that helps us in simplifying expressions, which are also known as laws or rules. And now we will discuss about these laws and rules in detail. Typically there are 7 to 8 important ones, and I have added 1 or 2 extras for you to learn, and we will go one by one to understand all these important 7 to 8 laws of exponents. We will start with the first one out over here, which says a to the power m multiplied by a to the power n is equal to a to the power m plus n, where a is an integer or a decimal number, and m and n are also the positive integers, which I have mentioned out over here for each one of us. So two things out over here, right? So we are looking at this law. What this law is named as, the name given to this particular law is product with the same basis. When they say product, they are saying sum of the exponents, and when they are saying same basis, it is the same base out over here, right, which is basically a multiplied by a. What we will do now is we will also see an example which will help us better understand this particular law. So imagine you have an expression which we need to simplify. So let's take an example now, example 1, and the expression that you have is 5 to the power 5 multiplied by 5 to the power 1. So imagine this is the same base like we have seen over here in this particular law. Imagine m is a value of 5 and n as a value of 1, and if you will apply the same formula or the same law that we have seen over here, this will read like 5 to the power 5 plus 1, and this will become 5 to the power 6. Yeah, so I hope this is clear. We are looking at law number 1, which says product with the same basis. The formula of product with the same basis is a to the power m multiplied by a to the power n, and this is equal to a to the power m plus n. We have seen an example over here where we have same basis and 2 exponents which are positive exponents, and when you will apply the same law over here, you will get an answer which is 5 raised to the power of 6. Now we will look at law number 2. Law number 2 says it is a raised to the power of m divided by a raised to the power of n. This will be a is equal to, this will be equal to a raised to the power of m minus n. And what is the name given to this particular law? This particular law or rule is being called as quotient with same basis. It is very important that we learn the law by their name so that you will be able to remember them next time when you will apply these particular laws and rules in your questions in the future. So pay attention, try to learn the name as well while you learn the equation or the law, and let's see how do we solve or how do we apply a law like this. So imagine if we have an example like this. Find the value when 10 raised to the power of negative 5 is divided by 10 raised to the power of minus 3. So your answer or response over here will be 10 raised to the power of minus 5 divided by 10 raised to the power of minus 3, and based on this particular formula or law, this will be, so 10 raised to the power of minus 5 divided by 10 raised to the power of minus 3, and looking at this particular law over here, we will write it like 10 raised to the power of minus 5 minus the value from the denominator here, which is minus 3. And when you will do the plus minus, this will read like 10 raised to the power of minus 5. Minus minus become plus. This will be 3. This will be 10 raised to the power of minus 2, plus minus minus, and then you will bring the symbol of minus over here because it is coming with the higher value. And then if you will do the inverse, this will read like 1 by 100. So this is the explanation about the quotient with same basis, which is the law number 2 that we have learned over here. Now we will move to the law number 3. Law number 3 is about a raised to the power of m raised to the power of n is equal to a raised to the power of m and n put together. Now the name which is being given to this particular law is power raised to a power, because and you will be able to resonate to this particular name because this is the power which is being raised to a, and then on top of this there is another power which is being raised, and the answer to this is a raised to the power of m multiplied by raised to the power of n, and this is why it is being said power raised to a power. Now let's try and apply this particular formula or law in a real-time example. So we will look at example here. It says express 8 raised to the power of 3 as a power with base as 2. So what does this mean now is, so the ask is that we need to express this as a power with the base value of 2. So what we already know is we need to keep the base as 2. And this is the power that we will have to apply. So in order to get into the solution mode, we will have to first break the value of 8 into the exponent format. So what we will have to do as a solution, we will have to say 8 is equal to 2 into 2 into 2, because 2 into 2 is 4 and 4 into 2 is 8. Yeah. Now if we will have to convert this into the exponent format, this will read like 2 to the power 3, and therefore our answer will be with the base value of 2. We will say 3, which will convert this 8, and then overall it will be 3. And now if we will apply this particular law here, this will be 2, which is the base, raised to the power of 3 as m, and multiplied by raised to the power of 3, which is n as an example or n as a formula here, and this will be 2 raised to the power of 9. I will quickly explain this once again. We are looking at law number 3, which is a raised to the power of m and then super raised to the power of n, and this will be equal to a raised to the power of m multiplied by n. The name of this particular law is power raised to a power, and the example that we have taken up in order to explain this particular law is express 8 raised to the power of 3 as a power with base value 2. Now in order to making sure that we use the base value of 2, we will have to bring this 8 figure into the exponent format. So this will be 2 into 2 into 2, which will be 2 raised to the power of 3. And when we have got this 2 raised to the power of 3 as an exponent figure for 8, we will write it over here, and then the overall 3 as the power, we will write it over here. Now this will, and if we will follow the law of exponent, which is power raised to a power, this will get converted into a raised to the power of m multiplied by raised to the power of n, and this will be 2 raised to the power of 9. This is your answer. Law number 4 is a raised to the power of n with b raised to the power of n is equal to ab raised to the power of n. Now this is an interesting one, and it is also being called as a product to a power. And here we will notice in the law number 3 and law number 2 we were having the same basis, but over here we have two different bases, which is a and b. This is an important thing that we will have to notice. If the bases are different but the power is same, then we will use this product to a power. So I will repeat, if we have two or more different bases, but if the power is same, we will use this law. And let's understand this particular law with an example. The question is simplify and write the exponential form of 1 by 8 multiplied by 5 raised to the power of minus 3. Now how do we solve this with the help of this particular law which says product to a power? So in order to solve this, we will have to look at the first base, and the first base is basically saying 1 by 8. This will be 1 by 2 into 2 into 2 is equal to 1 by 2 to the power 3, right? Now we need to make sure that the exponents of both the bases is same, which is not currently. So the exponent for this particular base is -3, the exponent for this particular base is +3. So in order to convert this positive into negative, we have learned about inverse solution, and the inverse of 1 by 2 to the power 3 will be 2 minus 3. So now our equation, this total equation will read like 2 raised to the power of minus 3 multiplied by 5 raised to the power of minus 3. We have two different bases but the same exponents. This will read like 2 into 5 raised to the power of minus 3. And eventually you can write it like 5 into 2 is 10 raised to the power of minus 3. This will be your answer. So I will quickly repeat. We are looking at product to a power. The definition of product to a power, or the criteria of product to a power law, is that if you are having two or more different bases but with the same exponent, you can apply them or you can write them like this. Now we have taken an example over here, 1 by 8 multiplied by 5 raised to the power of minus 3. Both the bases are different, however their exponents are not the same. So we will have to first make sure that we have the same exponents in order to apply this particular formula. So 1 by 8, if you will convert this into the exponent format, this will come as 1 into 2, 1 by 2 into 2 into 2. And then when you will convert this into the power, this will read like 1 by 2 raised to the power of 3. And when you will do the inverse in order to convert this into the negative, so that you have the same exponent here for base number 1 and same exponent here for base number 2, you will have to do the inverse of this particular exponent, and this will read like 2 raised to the power of minus 3. And when you will apply 2 raised to the power of minus 3 in place of 1 by 8, it will read like this, and 5 raised to the power of minus 3 will read like this. And when you will apply this particular law, this will be 2 multiplied by 5, which is AB, raised to the power of minus 3, because the power or the exponent for both the bases are same. And this eventually will read as an answer 10 raised to the power of minus 3. I hope you are following me. I hope you are learning from what we are discussing right now. These are some very, very interesting laws of exponents that we are exploring, we are learning about. And once you have a solid understanding about all these laws, you will be able to solve any question from your chapter 10 of exponents and power in your class. And not only you can solve it for yourself, you will also be capable of then explaining the laws of exponents to any of your friends or students around you. We will now look at law number 5, which is a raised to the power of n divided by b raised to the power of n is equal to a by b raised to the power of n together, and this is called as quotient to a power. What does this mean is, or what does this law means is, it says the fraction of two different bases, and I will write it very quickly. The fraction of two different bases with the same power is represented as above, like this. And we will understand this particular law with an example also now. The example we will choose is simplify the expression and find the value of 15 raised to the power of 3 divided by 5 raised to the power of 3. So we have two different bases here. 15 is base number 1, 5 is base number 2, and we will apply the same law that we have learned about quotient to a power. So I will 15 to the power 3 by 5 to the power 3. This will become 15 by 5 to the power 3. This will further become 3 to the power 3. This will become 3 into 3 into 3 is equal to 27, and that's your answer. And that's how you simplify the expression to find the value with the help of law of exponent number 5, which is quotient to a power. Again, quite very simple if you will understand it step by step. Two different bases are there. 15 is base number 1, base number 2, based on the explanation that I have given, with same power is represented as, and the power is same out over here, the exponent is same out over here. So you will use the formula, you will use the rule, you will use the law, which is a to the power n, b to the power n, where n is same power or common power, and then you will write the right hand side of the formula, which is a by n common power 3, and then you will do something like this and you will get a result of 27. Let's look at rule number 6. Rule number 6 is a raised to the power of 0 is equal to 1. We have discussed about this rule in the part 1 video also a little bit, but very quickly, when the power, this is basically called as 0 power from a naming convention, the way we have this one as a quotient to a power. And the definition of this particular 0 power, or a raised to the power of 0 is equal to 1, is when the power of any integer is 0, then its value is equal to 1. So what does this say is, if you have an integer where the exponent of the power is 0, then its value is 1. It's not 0. So you will have to understand this very carefully so that we don't make mistakes as we start solving the questions or exercises in the future. And all these laws, right? We have seen 6 laws so far, and in total we will talk about 8 laws. And once you will master these 8 laws, again you will be in a situation where you will be able to solve any question from your chapter number 10 for class 8 very easily, and you will also be able to explain the concept and the laws to the other students also around you or in your friend circle. So let's just continue to focus on this particular law of exponent right now. So how do we now apply this particular law in one of the example? Let's take example here. Let's find out what is the value of expression 5 raised to the power of 0 plus 2 raised to the power of 2 plus 4 raised to the power of 0 plus 7 raised to the power of 1 minus 3 raised to the power of 1. Very interesting question, and this will basically clarify how do we apply zero power law in an expression like this. So this will become 5 to the power 0 will become 1. This will become 4. This will become 1. This will become 7. This will become 3. I hope there is no doubt here, because the power 3 is to 1. 3 raised to the power of 1 is 3 into 1. I hope there is no confusion here, and now we will do basic maths. This will become 6. This will become plus 4 after subtracting 3 from 7, and your answer will be 10. So this is how you apply the zero power in an expression to solve the question and get the final answer. We will now look at the negative exponent rule, which is basically rule number 7 or law number 7, and it looks like a raised to the power of m is equal to 1 by a to the power m. It can be also written as a raised to the power of m is equal to 1 by a raised to the power of m. And again, this is called as negative exponent rule. And the description of this particular law is, if the exponent is negative, we can change the exponent into positive. We can change the exponent into positive by writing the same value in the denominator, by writing the same value in denominator, and the numerator holds the value 1. So if the exponent is negative, here the exponent is negative, we can change the exponent into positive by writing the same value in denominator. So we are basically saying in the denominator we will write the same value and we will convert the negative into positive, and in the numerator holds the value 1. So this will become 1 by integer and exponent to positive from negative. Now let's understand this particular situation with an example. Find the value of 2 raised to the power of minus 2. Okay, so here 2 is the base. You have a negative exponent. How do you convert this into a positive? With the help of this particular law, which says negative exponent law. So your answer will be 2 raised to the power of minus 2 is equal to 1 by 2 raised to the power of 2, because now with the help of this particular law, you will be able to convert your negative exponent into positive 1. And if you will further expand this will be 1 by 2 multiplied by 2. This will become 1 by 4. This is going to be your answer. And this is also known as inverse or reciprocal. So for an example, a raised to the power of negative exponent is equal to reciprocal of 1 by a raised to the power of positive exponent, or otherwise we can read 1 by a raised to the power of positive exponent is inverse or reciprocal of a raised to the power of negative exponent. So remember, we also call this as reciprocal or inverse. Once we will learn all this law, any questions may come in front of you. You will be able to solve those questions with the help of all the learning that you have done so far in this particular video, and all the learning that you have done around laws of exponent as well. So let's continue. Let's look at the last law of exponent in this particular video. And law number 8 is a raised to the power of 1 by n is equal to n root of a, or it is also called as nth root of a, and this is called as fractional exponent rule. And by definition, fractional exponent rule is used if the exponent is in the fractional form. And by definition, the fractional exponent rule is used if the exponent is in the fractional form. So this is the fractional form. You have an integer and this will be equal to nth root of integer. Let's understand this particular law with the help of an example now. And the example we will take is simplify 4 raised to the power of 1 by 2. Right? So we have n as 2 over here. And the solution or the answer over here will be for this. Given the exponent is in the fractional form, which is 1 by 2, and according to the law and according to the fractional exponent rule, 1 by 2 can be written as root 4, which is basically 1 by 2 is equal to root 4. Now 1 by 2 is equal to 2. Why? Because the square root of 4 is 2. Hence, the simplified form of 1 by 2 is equal to 2, and hence your answer is also 2. So I hope with all this you understand not only the fractional exponent rule, which is basically a raised to the power of 1 by n, and then this n becomes the square root of the integer or the number. And we look at the example 4 raised to the power of 1 by 2, and then we wrote it like a raised to the power of 4 is equal to square root of 4, and when we calculated the square root of 4, it is 2, and your answer is 2. So we have seen 8 laws of exponents, and very quickly I will walk you through all of them. A very quick recap. Number 1 was product with the same basis. So if you have same base with different exponents, you will give this kind of treatment. This is number 1. Number 2 was quotient with the same basis, wherein you have same basis like this divided with each other with 2 different exponents. So you will do a subtraction over here as a part of the formula or as a part of the law. Then we looked at rule number 3, which was if you have a situation like this, you will give this kind of a treatment where you have an integer, you have an exponent, and then you have power raised to a power. So you will do a raised to the power of first exponent multiplied by the second exponent. Then we looked at rule number 4, product to a power with 2 different bases. If you have a situation like this, you will give this kind of a treatment where you have 2 different bases but with the same exponent. Then we looked at law number 5, which is basically exponent to a power, where you have 2 different bases and you give this kind of a treatment. Then we looked at law number 6, which is 0 power, and we learned that any integer where you have the power of 0, it will be considered as 1 and it will not be considered as 0. Remember this is a very important thing, and most of the students make a mistake here. So if you have any integer where the power raised is 0, the answer is not going to be 0, the answer is always going to be 1. So keep this in your mind and remember this particular important law, which is 0 power law. Let's look at law number 7. Law number 7 is also known as reciprocal or inverse law, where you convert a negative exponent into a positive exponent. We called it as a negative exponent rule or law as well. And likewise, you can convert the inverse of positive into negative as well in your expressions when you are solving the real-time exercises. Last but not least, we learnt about 2 things over here. One, we learnt about the fractional exponent rule. Secondly, we also learnt about square root and how do you calculate the square root. Again, a very, very important one. Most of the students struggle in this particular rule. So it is important that you understand this particular rule and practice it as much as you can so that you have a good control. And it is not only about the fractional, but also understand how do you calculate the square root. So keep this in your mind, and we will continue to apply all these laws in the upcoming exercises. Thank you.